Okay, so very good morning guys. Once again, this is the lecture 2 of the series of current electricity for boards. Okay, so in the last lecture we have discussed about the drift velocity, correct? So let's write down and let's start this lecture with the definition of drift velocity. So we can say the average speed gained by electron in average time, that is relaxation time, when electric field is applied is known as drift velocity. Okay, how much you are drifting in relaxation time, correct? When electric field is there, it is known as what? Your drift velocity. Very good. Now, as you can see on this board, there is something which is also written as what? Mobility. So mobility is something, a topic which is also connected to what? Drift velocity. Hai? So basically, mobility is defined as the ratio of drift velocity divided by what? Divided by electric field. So mobility is the ratio of drift velocity and the electric field. So mobility we can write it as what? Drift velocity upon electric field. Write down the formula E tau by m. E getting cancelled. So we are getting mu equals to E tau by m. Do it by yourself. Pause the video and do it by yourself. VD is nothing but you just calculated in the last lecture. E tau by m divided by E. Correct? E will get khalas. So basically, correct, mobility is coming as what? Negative E tau by m. Very good. Achha. So now you will ask, sir, what this mobility indicates, what this mobility suggests. So basically, this suggests what is the speed or how quickly your all charges are moving. Okay, or correct, because to conduct electricity or for conductivity, correct, it is very important for the charge to move. How quickly your charge is moving. Mobility suggests that. Okay, it indicates that. So something which we can do in the chapter 14. Okay, material of chapter 14. So over there we will set up a relation between conductivity and mobility. Chalega? So, but they can directly ask you, and I think they will ask you in all these examination, right? In final examination to in board examination, they can ask you. But more importantly, they can ask you this half-yearly examination. So very important thing that you should remember. Okay, chalega. Mobility, very important thing. So remember what is the definition and what is its formula. Now, chalega. Okay. Okay. Now, if we are writing the mobility for electron, it will be what? Negative E tau by m. If we are writing the mobility for positive charge, it will be Q tau by m. Okay. Chalega, what is tau? Yes. Tau is what? Your tau is what? Tau is your relaxation time. Tau is your relaxation time. Tau is your relaxation time. ठीक है भाई? Okay. M is what? Mass of charge. Over here, your charge could be electron, your charge could be anything. Yeah? So it could be proton, it could be alpha particle, anything like that. So M is what? Mass of charge. ठीक? चलिए. खत्म? Okay. Now, the next topic is very important. That is how will you set up the relation between current and drift velocity. Very important thing. Okay. So before discussing this, let's discuss what is current. You will see, sir, current, as that was topic 1, correct? As we discussed, it was charge upon time. So I would say, what do you understand by charge upon time? You will say, sir, charge is there, time is there. That is current. Basically, current is how much charge is passing through a certain cross section in given time. What is charge? What is Q? What is Q in the formula? It is the amount of charge that is passing through the some cross section area in time t. That is known as what? Your current. Okay. So this definition is very important. We will write it down. Don't worry. We will write it down. But this definition is very, very important for this derivation. Okay. So relation between I and Vd. Okay. I and you can say drift velocity. Okay. So it will come out as, we all know that drift velocity is what? Vd. What is drift velocity? Vd. Then okay. So our final answer, it is going to come as neat. What do you understand by neat? What do you want to say? We have to derive this thing. I equals to NEAVD. Okay? I used to call it as neat. Neat. NEAV. So short trick. Just to remember it, I equals to neat. Right like this. Neat. Neat. It means foundation in knee or foundation. Okay? Knee or foundation. This is short trick to remember it. Otherwise, after some time, you might forget. Okay, it was what. That's why I'm saying. Okay, knee. Okay, NEAVD. Chalo, let's derive it. So basically, when we say that current equals to charge upon time, we should say Q is the amount of charge passing through the cross-sectional area in time t. Okay? So the amount of charge passing through the cross-sectional area in time t is known as what? Your charge. Now, charge upon time is your current. Or can I, if you are really okay till this point, can I also write this current? Can I also write this current as I equals to dq by dt? So both of the formulas are correct, but this formula is giving you more precise value. I equals to dq by dt. Now, okay, please have a look. Then we can move on to the next page. Done, guys? Done, guys? चलो, let's derive it. आजा रे भले कितने लंबे रास्ते हो, थकी ना तेरा ही तन हो। आजा रे इस धरती का है राजा तू, यह बात जान ले तू, कठिनाई से टकरा जा तू, सुनतवा तुझको क्या डर है, धरती अपनी है यह अपना अंबर है रे, ओ मितवा सुनतवा तुझको क्या डर है रे, ये धरती अपनी है यह अपना अमर है। देख चल. So basically this is the cross section area 1. Okay, pink one is cross section area 1, green one is cross section area 2. So what is happening over here, you can see there is a battery attached to this conductor, correct, and electric field is there, so that's why the electrons they are moving, बेचारे electrons they are moving in this direction, correct, बेचारे electrons they are moving in this direction. Okay. If we want to calculate the current inside this whole conductor, we should know कि भाई साहब what charge is passing through these cross sections. Okay, now let's focus on cross section 1. Let's focus on cross section 1. So on cross section 1, can we see clearly that in time dt, these all charges will pass. Like the wave was coming in dt time, in time dt, all these charges passed with velocity vd. Or we can say कि देखो this is length. देख अच्छे से कि the length over here between these two cross sections is nothing but velocity into time. Yes or no? So with what velocity? With drift velocity. With how much time? In how much time? dt time. पक्का क्या? Okay, electrons are coming from here and in dt time. Shoot. They travel how much distance? L or vd dot dt. Yes or no? Or we can say these all electrons have passed through the cross section area. Okay. अच्छा एक काम आ जा. So can we say that this area is A? ठीक है भाई. This area over here is A. Okay. Now can we say that the one thing that we should discuss over here, we should derive over here, or we should just introduce over here, that is what? Current density. So first thing, N is your current density, or N is your what? Current density. ठीक है भाई. अच्छा. So second thing, how will you write volume between 1 and 2 cross section? You will write area into length or area into Vd dt, correct? You will write like this. This is the volume V. This is the volume V. Achha, why we are writing this volume? Because see, what is your current density? Achha, I'm writing. I'm so sorry. This is not current density. This is charge density. This is charge density. So charge density is nothing but charge upon volume. If I'm asking you, if you have to calculate number of electrons or number of charges, then you should multiply what with current density. Charge density. With what factor you should multiply to charge density such that you will get charge? Obviously volume. Dekh bhai, if you want, you will multiply with what? You will multiply with volume so that you will get what? You will get what? Charge. Correct? Very good. चलो भाई. Okay. ठीक. So now third point बस खत्म हो गया. कोई बड़ी बात नहीं. I equals to dq by dt. अरे गलत तो नहीं बोल रहा. I equals to dq by dt. Very good. Okay. So I equals to dq by dt. अरे ऐसा भी बोल सकते हैं कि n dq is the charge that is between how much? dq is the charge that is crossing cross section 1 in dt time is nothing but the number of charges that is there between cross section 1 and 2. देख अच्छे से. dq over here, अच्छा यहाँ पर देखते हैं. dq is the charge crossing cross section 1 in dt time. ठीक है, dq is the charge crossing cross section 1 in dt time, or we can say this is the charge between 1 and 2. Okay, so this is the charge between that is enclosed over here. Correct? Are we getting it? This is the main point. If you are able to understand this, then khatam ho gaya. Correct? The number of charges that are passing cross section 1 in dt time is nothing but the same charge that is enclosed between 1 and 2. Correct? Dekh, in dt time, look carefully. Huh? These two hands, let's say, these are the number of electrons that are passing in dt. Dekh, these all electrons are passing dt, sorry, this cross section 1 in time dt. Correct? Or we can say the charges that are there in between 1 and 2. तो कैसे लिखेंगे भाई, how many charges are there? Obviously charge density into volume. बस खत्म हो गया, आ गया. देख, dq is charge density into volume. पक्का? into volume. तो ये क्या हो गया आपका, number of charges, okay, and into electron का charge. Correct? q is what? Ne. Correct? Number of electrons into charge of electron. So over here n is charge density, you will multiply with volume, you will get number of electrons into electron divided by dt. Correct? Yes or no? Okay, so n volume will be what? A dot A into your length. Correct? Dot E by dt. Your length was what? Vd dt. Correct? dt getting cancelled out. Okay, so I is nothing but n e a v t. I hope you are getting this whole derivation. Okay, important point, if you want to write over here, just for your understanding, that charge is nothing but number of electrons into electron. Correct? Total charge is what? Number of electron into electron. Correct? Number of electron will be nothing but n into volume into E. Okay? Few things just to understand it better. We are writing. Okay? Chalo. I hope this whole derivation is clear to all of you. One more time. Okay, we are defining, we have to draw this whole thing like this. Okay, and over here we have to make the diagram. We have to show the electric field from where to where, cross section 1, cross section 2. We all know that electrons, they move in the opposite direction of the electric field. Okay, so N is the charge density, charge upon volume. Okay, so with what one thing we should multiply to the charge density, so that we will get charge. Obviously we should multiply with volume. Okay, we will get the number of charge. Now if we are multiplying with electron, we will get total charge. Okay, now how can we write volume? Volume is nothing but area into length. Length is what? Just drift velocity into dt. This was the important part. After that, everything over here is halwa. Correct? So I equals to dq by dt, and into volume into electric, like charge of electron upon dt. Okay, L is nothing but drift velocity into dt khalas. Okay, so I is coming as NEA dt. Look carefully, guys. One more time. Look carefully. Look carefully. Are you getting it? देखो अच्छे से. Okay, चलो. Now, so we are done with the derivation. Now, Aja. So based on this derivation, we will derive Ohm's law. Do you remember Ohm's law? V equals to IR. Do you remember that? V equals to IR grade 10. सर ऐसी बातें कहाँ याद रखते हैं लोग? 2 साल पुरानी बातें आप पूछेंगे तो कैसे याद रखेंगे? बिल्कुल सही. चल, आ जाओ. So this derivation I equals NEV very important. है? चल. Now write down Ohm's law. Ohm's law. अच्छे से देख. ठीक. I is nothing but N E A V. ठीक है? Correct? Okay. Now, can we write VD or drift velocity as सोच क्या था? E. I'm just writing the magnitude of drift velocity. Okay? So please do not get confused with negative sign. I'm just writing the magnitude of drift velocity. ठीक है? चल. So E tau by m. Yes or no? E tau by m. Correct? Okay. So now can you see electric field? Very good. Okay. So we can also write it as E into E. E square will come. E square A नीचे आ जाएगा m ऊपर tau into E. Correct? I'm just writing E with a different color. Okay. Now, ask yourself, how can we write electric field in terms of potential difference and length? How can we write electric field in terms of potential difference and length? Yes, my friend there. Yes, my friend there. You are all set. You are all good. You are all correct. You are all correct. So, it can be written as potential by length. आया? ठीक है? अब अच्छे से देख. Now, look carefully. What was the Ohm's law? I equals to, you are getting NE square A tau M L, and you are getting what? 2 important characters. Can you see 2 important characters? Can you see 2 important characters? I and V. Okay. So by looking I and V, what was the Ohm's law? Ohm's law says that the ratio of V or V upon I was constant, or V was directly proportional to I. Look over here. V is directly proportional to I. Correct? So from here, we can write, if you want to write like this, okay, ML upon, अच्छा, confuse, मैं ऐसे लिखूँ, okay, V को साइड में, easy, V equals to I into, when this whole masala will go over there, it will become what? अच्छे से ML divided by N E square A tau. ठीक है? So this is nothing but your resistance. This is your what? Resistance. ठीक है क्या? So from here we got V upon I equals to R. और पहले कैसे equals to I. Okay? और this is what Ohm's law. V equals to I or V upon I equals to I equals to constant. This is known as what? Ohm's law. I'm not confusing you guys. I hope you are getting it. You already know these all formulas. Correct? Correct? So what did we do in Ohm's law? We did nothing. I equals to NEAVD. We just derived it. Put VD, which was drift velocity, what in its basic formula, E tau by m. After that, try to write down the electric field in terms of potential difference V by L. Now you have two characters emerging, I and V. Look carefully, you have to create what? V equals to IR. So send this kachra over here, ml in the numerator, n square a by tau denominator, correct? So ml upon ne square a tau, correct? It will become what? R. Okay, so we derive this V equals to IR, or V upon R equals constant. This is known as what? Ohm's law. This is the backbone or the lifeline of this whole chapter. Okay, Ohm's law. Okay, look carefully. See, while deriving this, few things that should be there in your mind. That is, how can we create potential over here? How can we create potential difference? Because VD, you are creating electric field. From electric field, you are creating potential difference. Correct? So think about it. In formula of I equals to NAVD, how can we come to potential difference? By VD, we can come up to electric field, and after that, we can come up to potential difference. Correct? Right? Yes. So this is the logical way. If you are able to do like this, this whole thing is nothing but just a logical thing. But if you are memorizing everything, it will be a bit difficult for you. Right? So I would say, understand this. Do not memorize this. By understanding it, this whole derivation will be nothing but a halwa. But if you are memorizing it, so it will be, a painful, rough journey. Yes, anyways, if they are asking you derivation, if you are writing as it is by memorizing or by logically, you will get full answer. But yes, the process will be easy. That's what I would say. Okay. Done, Janta? Are bolo bhai? Done? Done. Okay. We derived very important two derivations in this whole thing. Chal, acha. Aja re. So the star points that we are getting from here is what? R is equals to, देख अच्छे से, R is ml divided by ne square 8 by tau. Okay, so we can write like this: ml upon n e square tau a. Okay, so do you know that this is known as resistivity, rho? Okay, so that's why R comes out to be rho L upon A from this derivation. I hope now you are getting why we used to write R equals to rho L by A, okay, in grade 10.
Okay.
कुछ पानी एक और होगा नहीं हाँ ये 28 मिनट का हो गया लगभग। हाँ तो नहीं अब अभी बस थोड़ा सा और कर लेता आप आ जाओ, कोई दिक्कत नहीं।
नहीं बिल्कुल मैंने आपने रोक दिया।
नहीं कोई दिक्कत नहीं, ये तो हो जाए। आ जाओ
वो सही पानी
So R equals to what? Rho L by A. R equals to rho L by A. Okay. Now, from here, we understood how resistance was coming as what? In terms of resistivity, length and area. Rho is what? Your resistivity. ठीक है भाई? चल आ जाओ. We will discuss about this resistance after some time. Firstly, let's discuss about Ohm's law, and then after that we can discuss about what resistance. चल. Okay. So now this topic is related to limitations of Ohm's law. How Ohm's law we want or we have studied in grade 10, how it's a bit different for different things, okay, at different potential or something like that, okay. So let's discuss it over here. So firstly, अच्छा एक चीज और कर सकते हैं, एक ग्राफ बना सकते हैं so that you can understand that V equals to IR. So if V is here, I is over here, so current will be a, sorry, this whole graph will be a what? Straight line passing through what? Origin. Straight line that is passing through our origin, okay. And over here, if someone is asking you what is this, if this is theta, then tan theta is your slope, which is nothing but r. Right? So if graph is given and theta is given, let's say 30 degree, so 30 degree is what? Tan 30 degree is what? 1 upon root 3. 1 upon root 3 is your resistance. They can give you the graph and they can ask what is the resistance, okay. Check. Now, so going on to the next page. Check. Now, so variation no, not variation, limitation, sorry, limitation of Ohm's law. Or what? Limitation of Ohm's law. So there are three limitations that are given in NCERT. So I'm going one by one. Okay. So first limitation, okay, that is that कि when you increase the potential a lot, or when you are increasing the current a lot, V versus I. Okay. So this is the line V equals to IR that your curve was supposed to follow. But in reality, what happens? In reality, this happens. Okay? It slightly deviates from this line after a certain point. Okay? So, after certain voltage, the curve is not following Ohm's law. Okay, check. Now, second thing, this happens where? In conductors, in metals. This happens where? In metals. Like what? Copper हो गया, iron हो गया, aluminium हो गया, gold हो गया, silver हो गया, सारे यहाँ पर पास. Now, second. Okay. So, V versus I in semiconductor. Look carefully how the graph of semiconductor looks like. When you are do one thing. Over here we are writing I, and over here we are writing I. मतलब फर्क कुछ नहीं पड़ेगा. Okay. Now in semiconductor we are writing I. Again it should come as what? Straight line, correct? For this thing, that's what we are expecting. But in reality, for semiconductor, it comes out like this. If potential is positive, Okay, but when we are thinking, if we are reversing the what voltage, if we are putting the battery in opposite sense, that this whole thing should be repeated, yes or no? Then current, it should be like this, yes or no? The predicted thing should be like this, कि भाई ऐसा आना चाहिए, correct? But in reality, it came out as what? But in reality, it came out as this. Okay? It came out as this. Okay? So, this thing is also a limitation, because when you are reversing the polarity of cell or battery, the current should follow that, but it is following a very different curve. Okay? So, this is another limitation. Where? Semiconductor. Or where? Semiconductor. कहाँ हो गया भाई? Semiconductor. ठीक है? चलो. This is the second limitation. Now, are you able to see? For metals or semiconductor? For semiconductor, we can write when we reverse the polarity of cell, the IV curve is different. Okay, it is very different than the expected. Okay, few things that we should know. Now, coming on to the third limitation. Coming on to third. In few of the compound, I versus V, okay, it is following, yes, Ohm's law for a certain time. After that, okay, it's not even following it. Okay? After some time, it is not even following the Ohm's law, right? So basically, you can say the I versus V at two voltages, you have same current. So uniqueness is lost, because at two voltage, at two different voltage, the current is same. So uniqueness is lost. Okay, so over here at two different voltage, current is coming as same. Are you getting it? So this uniqueness is lost, and this generally happens in gallium arsenic compound. Okay, done, Janta? Okay, and this generally happens in where? Gallium arsenic compound. Okay, very good. So we discussed that what are the limitations of Ohm's law? That after some time, the whatever whether it's metal, semiconductor or some compound, they are not following the Ohm's law. Okay, so that region is known as non-ohmic region. Ohmic region means what? Where your resistor or your metal, semiconductor or your material is following what? Ohm's law. So the limit till the material is following the Ohm's law, it is known as what? Ohmic region. Whenever the material is not following the ohmic law, right? The Ohm's law, it is known as non-ohmic region. Something you should write. Anyways, if you are not writing it, you will understand. But let's say ohmic region, material following Ohm's law. ठीक है, नॉन ओमिक रीजन, material not following Ohm's, ठीक है, चलिए, where material is following Ohm's, material is not following Ohm's law. Okay, so ठीक, so now we are ending this lecture over here. In this second lecture, we understood how can we derive. Firstly, we started with mobility, correct? What is the meaning of mobility? How will it be used in 14th chapter? But definition is important. After that, we moved on to the derivation. I equals to NEAVD. From there, that was our what foundation? Knee. I equals to NEAVD. Knee foundation. From there, we built our houses of Ohm's law. Okay, Ohm's law we derived from there. V equals to IR. Remember, how can we connect? I equals to NEAVD. How can we create electric field on RHS? And after that, creating electric field, how can we write electric field as potential difference upon length? Okay, so from there we are creating or we are getting Ohm's law. V equals to IR. Correct. From there, we also get to know that what is R. Right? V equals to IR. What is R over there? From there, we also noted it that R was rho L by A. Correct? R was rho L by A. And after that, we discussed on few of the limitations of Ohm's law. Okay? How the materials over here, they are behaving very differently in very, very different situations. If material is metal, semiconductor, or your some compound. Okay? So thank you so much, guys. As always, have a nice day.